Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about SpaceX Stainless Starship update. So let's dive right into it. Well, first you have to understand there have been many smaller events, but there were some few big milestone in the development of Starship. So first one was that Starship now has NASA support. Why does that matter? That think of it this way: whenever a company like SpaceX is doing something, they still have to make money. Yes, they are not on stock market, but they still have to make the profit. So problem of that is like there is no demand for something as huge as this puppy. Reason for that is think of it this way: they already built Falcon Heavy, but how many launches of Falcon Heavy have been there? Not that much. And given you to give you a context of that, this puppy can launch around 100 tons to low Earth orbit. That's the basically goal for it right now. But here's the biggest object we have in space is around International Space Station. That's around 600 tons, give or take. Somebody says it's 400 tons, but again, because there are more modules that are added and removed, things of that nature. But here's the biggest component of that unit was still under 30 tons. So Falcon 9 can easily do it. So reality is there is no demand for something this powerful, this huge. So that means there are not that many pre-orders for it. And if there is no pre-order, how the heck they're gonna get the initial funds to develop it? So that's why they really need people to be more excited about it. That's why they need investor to be excited about this. Like, okay, even if it's not a stock market, people may still want to give loans or donations, things of that nature. So that's why that NASA support is very important, because NASA is like, okay, we want to go to the moon in 2024. Now whether they can do that or not, that's not a big deal. But point is, NASA is very determined about this, and they are funding 3 independent systems, and SpaceX being one of them, that gives them a very big boost. It's like, okay, somebody is serious about them, because if you are familiar with SpaceX development, there is always somebody backing it up. For example, a Raptor engine has Department of Defense backing it up. So yes, there is a serious amount of development money that we are talking about. So that little bit push is more than enough at this point in time to push this into high gear. And that's first. Second, the first launch they had, it was just a dummy, just get something together, just fly it, and tada. This time they have successfully flown a full-size fuel tank. So at this point in time, with current iteration of that design, this is supposed to be the fuel tank. They actually managed to build the tank and load it with propellant, fly it, land it, check it, everything is good. So that's a very big achievement, because again, you can design anything in your head. It's like, it's gonna be 20 meters tall. Once you actually built it, wait a minute, it collapsed under its own weight. Things of that nature happen. So that full size testing, good. Another, Raptor engine, because of the ambitious aim of this puppy, they want to make Raptor engines 1 engine a day. That's their goal. Now in early days, they would have been lucky if they were getting around 2 months per engine, but right now their current specific data point says they are at 1 week or 2 week maximum per engine. That's really good. That's like lightning fast compared to every other manufacturers. It's like, whoa. It's on a different scale, but to make the cost of Starship lower, they have to go much faster than that. So they have to shrink that 1 week to 1 day. Can it be done? They are saying they have to modify a lot, refine a lot. Basically, they are no longer in a phase of designing the damn thing. They are in the phase of optimizing the thing. So that is also progressing along well. So they are happy with this. It's like, okay, we got the engine, we got some support. Some people are taking it seriously. Let's do this, and we actually built a full-scale sign. At that point, it's like, whoa, this is going to be a big puppy. So everything is good. Now, one thing you have to understand, SpaceX, when Falcon 9 was built, they were a very tiny company. What does that mean? That simply means they did not have the luxury that NASA has. NASA can, make their own road, or have their complete independent control over road system. Like, okay, I'm going to block this whole road. I'm going to, ship a giant fuel tank over it. SpaceX could not do that, could not afford to do that. So reality was, there was very serious limitation put onto Falcon 9. And the biggest example of that is their diameter. It's surprisingly tiny. Diameter wise, it's not huge. Why it's not huge? It's like way too slim, like it's like a pencil. It's not supposed to be that way. The reason was that because they had to ship everything with the road, they designed it such a way that it can go through the minimum clearance required for international, I'm saying it's basically interstate highway or something like that. There was like a rule, 4.2 meters is the clearance. They made everything so it can fit below that. This time they are like, no more hoo-ha like that, we're gonna go all in one place. So they are taking vertical integration to next place. So the whole idea at this point in time is container ship is gonna come here truck wise. Basically they're gonna dump steel here, they're gonna make the damn thing here, another manufacturing plant will send them the engine, they're gonna make the rocket here and launch it from this exact place. Basically they're gonna launch it here and land it in this exact same place. That's why that's how they can manage something this huge. This will simplify their operational cost by a very large margin. We do not think of it as like how much money you have to spend just to move the damn rocket from point A to point B. But like if you go to Russian's system where they have a rail route where they are transferring the rocket, it's a huge expensive deal that they have to do. If they can optimize that, it's like, okay, it's much easier to ship trucks and container ships and all that. Container ship, I keep saying container boxes, like that. Do that and move the rocket when, because it requires completely precise, slow, stable, just move it small distance. So that's their aim, and they are working full steam ahead on that. And the development speed is mind-boggling. Even though world ended in 2020, their speed bounced back around February and August. They started to bounce back, and there are people living near to it, and they are doing live streaming from this place. It's mind-boggling fast. Like yesterday there was nothing, today there is a giant building, and tomorrow there is another giant building. So the speed is mind-bogglingly good. Now Elon Musk suggested on Twitter something that I found very interesting, that they want to make fuel on site. Now you have to understand this. If you have electricity anywhere on earth, you can make oxygen. Oxygen is free, we have it in the atmosphere, that's not a big deal. But making methane, that's very tricky. However, it gives them double advantage. First, if they can make it on site, it reduces one of the bottlenecks. It's like, hey, will the propellant provider can provide us fast enough? They're like, we got this one in hand, everything is good, awesome. And another aspect would be, this will also help them fine tune the process, which they may eventually want to use on Mars. So surprisingly good, but that's a bit far out, but they are laying the foundation of that, so to say. So that's the build plan, and it's going fabulously well. Now prototyping. Now many times I specify in many of my videos is that you have to understand the philosophy of the people behind it, rather than the like, okay, this person, how did they think? No, understand their philosophy, how they are driven basically. So this type philosophy is trial by fire. They are no longer like, okay, somebody says, like, of course there are many people who work in metal industry and they call metallurgist. It's their job, like they spend lifetime understanding, like, okay, this is how you weld it, this is the maximum speed you do not increase the speed because it will make it brittle or things of that nature. They're like, no, you said I can, let's say, weld it at 50 millimeter per second. What happens if I do 55? Okay, it becomes brittle. How can we solve that? So they have a different kind of approach. It's like, okay, fine tune each variable, keep changing variables after a variable. And you can see it's even in Falcon 9, so to say. Take Falcon 9 block 1 versus Falcon 9 block 5. They don't even look the same. Like even though they are Falcon 9s, they're completely different. So they have trial by fire. It's like keep changing until it goes boom, which it has. It went kaboom in one, it went really big boom in another one. So it happens. So they are changing design every single step. So it's like, okay, and you can easily see it. Like the first models, it looked like a trash can, because it was like one panel welded here, another panel welded here, and this time now they have like spool kind of things, and they are still not their final form. The final form would be, there will be one spiral welder rather than like rings. Right now they are in ring structure. The end game is they're gonna have one roll and it's gonna be like, so they will reach there sooner or later. And they have made multiple models at this point in time. Some people are claiming the SN10 has already been begun, like construction, nose cone has already been built, or things of that nature. And one person funded out something very interesting. Is like, all this metal that has been destroyed is like still big metals. What the hell you gonna do? Because of the perimeter wall, it's like, it's big launch site they're building. They're using the charred metal of these things as a perimeter wall. Kind of amazing use, so to say. And they are making one huge change. They are the first huge change was going from carbon fiber to steel. They are going, another huge change is changing the alloy. So they are going from 301 alloy to 304 L alloy. L simply means low content of carbon. The reason for that, I have provided a video down below of a metallurgist who deals with this sort of stuff. He explains this much well, but I'm going to give you a TLDR of that. TLDR is very simple. On a cryogenic level, the welding on this puppy would be better. Can you achieve that same welding strength on 301? Yes, but you have to anneal that puppy. Annealing a giant rocket is not an easy option. So they're like, nope, we're going with 304L. So that's some like a major development. Now, what are the big milestones they have to achieve before they are like taken seriously? Like, as in like serious by everybody, where the big investors are like, okay, we can give you some money. So final engine specification have to be finalized. At this point in time, engines are there, it works, it's good, it's solid, everything is good. At this point in time, most private companies would have been like, dude, we're done, stop developing on that, develop on something else. But they still want to push it further. The reason for that is they want to reduce the engine numbers. They had earlier their original presentation video and all that, they were a bit too crazy. They wanted like way too many engines, and they're like, engineers were like, bro, calm down, reduce the number of engines. So the engine right now in the current configuration is 30. They want to reduce it to 28. Now you have to understand that means you have to add that 2 engine missing power into all the engines. So they want to the benefit of that would be less complication, and complexity is the enemy of reliability. When you want to put humans on there, you want the damn thing to be reliable. For example, Soviet Union's moon rocket had way too many engines and it never got off the launch pad properly. So reality is they want to reduce the engine number. So engine is still not in a phase where they're like done, this is it, multiple engines in a single place. They have not done it yet. All the testing that you are saying is basically fancy hopper testing. So they are learning the algorithms, how to manage the engine, how to gimbal the engine, but only one engine. And there is a serious limitation. They can't have multiple engines firing that close to their build system without a sound suppression system. That would be very brutal, but they have to do it sooner or later. If they are planning to, even their lowest configuration is 28 engine, they have to do it. So that's a very big thing that they have to do. And finalizing the design at this point in time, whenever you see something like this is just for public relationship. This is just for showing NASA, okay, this is what our final size would look like. They are not in a phase where like this is basically, you know, Starship. They are not there yet. Flat out, only outer design, only some rough configuration have been done. I will be damn surprised if they actually took the tiny legs concept right. Literally, I would be surprised if they literally did not extend the legs. Legs are way too small. So designs have to be finalized, and they are saying themselves, it's not me, they're themselves like we still have to refine a lot of things. And actual orbital test at this point in time, 100-meter hop is not 100 kilometers. And once you go in upper stage, other things start to act in, like what will happen to the steel alloy that you want to use in temperature fluctuation, what will happen if it bombarded by, like, you know, very high radiation of valence belt, or even space. So all those things have to be actual, and the biggest test would be going through what we call maximum dynamic pressure, max q. That is the biggest test, like will your structure survive that? So there are serious amount of testing need to be done, and not to mention they have to do the landing safely. The reason for this is very critical. Dragon system has a launch escape system, so if something goes boom, they can handle the situation. Space shuttle did not have that, and it happened, a bad event happened, 14 people lost their life. So same could happen with this puppy if the landing fails. So they have to make sure the landing is perfect on both of those puppies, because if you want people to trust you, like, hey, I am trusting my life, my astronauts on your vehicle, your vehicle better be goddamn sure. It's like, no, I'm gonna land here, and I'm gonna land safely. You can take it to the bank. You want to be that good. So they have to take this very seriously. Landing failure on this puppy would not be tolerated. So they have serious amount of milestones to achieve. Right now what they have done is just like, okay, project is serious, project is a go, project has started. Now, one thing you have to understand, Elon Musk is a very capable individual, undeniably so. And he's a human, like, he has 10 good ideas, 10 bad ideas, like Hyperloop, for example. But you have to understand that, like, undeniably on SpaceX front, he's going good. He's like, whoa. But one thing you have to understand at this point in time, whenever he says about timeline, listen to 1 year, remove it from another year. Just like, don't think about it. Timeline, he says, just add 3 years or 4 years to his timeline. Because be mindful, I'm old enough. I'm reasonably sure many of my audience members are old enough that they would have remembered Elon Musk claiming that he was landing on Mars on around 2018. So whenever he says anything about the timeline, just ignore that part. Everything else, awesome. Timeline, don't think about it. Timeline, no, don't think about that. So right now many analysts have actually started to drill down into NASA's doctrine is like, can you actually do what you want to do in 2024? And reality is likelihood is very low. And it's not like one analyst is saying that, it's like almost every company is like, dude, there's a very low chance that you can do that. I mean, like, SLS should have been done, but it should have been done few years ago. James Webb Telescope should have been launched few years ago. We are at a point where few years ago we have to call that. It's not 1 year ago, no, few years ago. So flat out, the probability of getting a successful moon mission 2024 is very low. And not to mention, it's this time we are not going go and come back. That's the difference part here. This time we want to go there and at least lay the foundation of early settlement there. So that's why this 2024 deadline is looking very, very unlikely. Now, human certification takes time. So even if, let's say, by some miracle SpaceX grew a lot, like as in they have to hire a lot of people and they have to get a lot of money. Let's say they did that. They grew, they hired a lot of people and they actually built the damn thing. Here's the human certification will still take time. For example, look at the human certification gap between Falcon 9 being ready, being Falcon 9 actually being certified. It takes time. And when you don't have escape system, that time would be extended. So That is their weak link at this point in time. And flat out, when I'm making this video, a few days ago, NASA, I'm saying SpaceX had a Mars conference or something like that, and he specified they are not started to work on life support system yet. And again, it's not surprising because a life support system would be developed in partnership with NASA. So that's a missing link, and you want to do a moon mission in 4 years? Yeah, that's not happening. So, and NASA did provide them money. That's no joke. They provided $150 million, but if Elon Musk is true, his own words, his own projected cost is $5 billion. So 150 is chump change at that point in time. So that is why they are rushing so much. That is why they are like, SN7, SN8, SN9, SN10. That's why they are rushing so much. So if they can gain NASA's confidence, and especially the budget, 5 billion for NASA would be like, who cares? Our James Webb Telescope is, I think, that budget. So that's not a big deal if NASA actually supports them. That's why they are rushing so much. It's like, get the goddamn confidence of NASA or Department of Defense. In either scenario, they will succeed. They have to get some confidence from that point. Another aspect, too many systems are untested at this point. Too many. It's not like, oh, this is if we can just build this game, game over, we are ready, we're good to go. No, they're like, okay, you build this, figure out how the heck you're gonna do the hydraulics, figure out how the heck you're gonna do the thermal management system, figure out how you're gonna do this or that or that or that. Like, too many subsystems are not taken care of. Like, you can see that even in aircraft industry, you will see an aircraft, it looks like an aircraft, you're like, hey, just assemble these things and it's good to go. No, it's wiring, and wiring could take up as much as a year. So to say, similar thing is happening with this also. And one individual did a quite amazing job. Is like SpaceX released the whole design of that interplanetary transport system in September 2016. That time he was launching by now, so that design was scrapped because it was too bonkers. Then they come down in the design. Then in 2017 September, a new design was unveiled. Then they came down even more, had the fin design and all that jazz. That happened in September 2018. Then that was scrapped, and another design was launched in December 2018, stainless steel design, and that design was scrapped. Another design was launched in September 2019. So you can understand, at this point in time, they are not in a position like this is the final design, this is what we are going with. Now some might say this is a very good thing. That's very good thing. It's very bad for your timeline. For everything else it's good, for your timeline it's really bad. That's why I'm saying, whenever Elon Musk says anything about the timeline, just listen from one ear, let it go from another. I don't know how many hyperloops should have been finished by now. So timeline wise, I would advise caution. Just take a deep breath, relax. Timeline is not gonna happen. Like, likelihood of a human rated Starship by 2024, it's very unlikely. And I'm putting my name here, my name Anupam Prabhu, I'm putting it down on 11/9 to 2020. I made a decision that by 2024 human rated Starship will not happen, most likely. So let's see, I could be proven wrong, but the likelihood of that is very low. At this point, I'm losing hair, I'm that old. So, and I have seen his antics before, so I know for a timeline wise, like everything else, awesome. Timeline, don't think about it. So this was my presentation on SpaceX Starship update. I hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.